Hey guys, welcome. This is lecture 29. In this lecture we're going to be learning about merge. So we'll learn how to merge datasets together by linking rows by keys. So we're going to import the usual. Oops. And from Pandas, import series data frame. Alright, so let's make a quick data frame. We'll call this data frame just dframe1. We'll do that with a data frame, and we're going to go ahead and pass a dictionary. So in this dictionary, we'll set off key, and I'm just going to put in some letters for the key. Let's just say X, Z, Y, Z, and let's say just XX again. Okay, and then the next entry in this dictionary is going to be the data set, so I'll just say data set underscore 1, and I'll set this equal to np.arrange 6. Let's go ahead and show that. Okay, so what happened here, we created a data frame. We did it through a dictionary. Dictionary data frames, you just set up your column name, and then you just set up a list of the data you want in that column. So the first column is data set, and then that second column was key. Nice. And then since we're going to be merging data frames, we need more than one. So we'll make another data frame. We'll call it dframe2. And we're going to do the same thing. We'll pass a dictionary. First entry we're going to call key. We'll pass 3 letters there, Q, Y, let's say Z. And then we'll pass the next entry, second data set, and in this case I'm just going to have it be a list 1, 2, 3. And then type dframe2 so we can take a look at it. Alright, so now we have data set and then a column called key. So now we can use the merge method, and this is a many to one method. So the merge will automatically choose overlapping columns to merge on. To show you what I mean, I'm going to call the method merge using pd.merge, and I'll call dframe1 and dframe2, the 2 data frames we have. Let's go ahead and see that. Okay, so what did merge do? If we look at the original ones, what are the keys they share? So data frame 1 has X, Z, and Y. Data frame 2 has Q, Y, and Z. So that means the only ones they have in common are Z and Y as far as the keys. And then if you look at their index, they happen to also be similar on 0Z and 1Z. So it merged those together and automatically overlapped where the keys matched. And I just chose this column and labeled it key for convenience so you could realize where it was being matched. Okay, so let's say I wanted to match on a specific column. I could do that too. Just by saying pd merge, you would enter the 2 data frame names, and then you can say on, and here you would choose which column you would want to merge on. So in order to get the same result by specifying this, I can specify to merge on that column labeled key, and I should get the same result as the automatic merging. And we did get the same result, so we know that works. We can also choose which data frames keys to use. And so to show you what I mean by that, let's go ahead and call pd.merge. We'll create dframe1, dframe2, and then we'll say on the key column, and we can specify how. So if I say how equal to left, let's see how that looks. We can pass that left argument, and let's see what happened there. So now we've passed them using the left data set. So you can see the data sets key values and index values are now being used. So if we look at dframe2, let's go ahead and find out why there are certain null values. So dframe2 had no x values, so it's going to say null for all the x values of the data frame on the left. And if we look at dframe1 and look at its key column was x, z, y, z, x, x. And since we specified we wanted to use that left data frame, it's kept the same key, x, z, y, z, x, x. To make sure you understand, let's go ahead and pass the right data frame. So the one on the left will be dframe1, the one on the right will be dframe2. We're going to label it on key, and how we'll label it now right. So we're going to pass using the right data frames key. So let's go ahead and see what happens. So if we take a look at dframe2, let's look at its key column. It was QYZ, and since we're on key, it only passed Q, Y's, and Z's. And the reason Z here is doubled was because it matched twice on both data sets, depending on the 0 index or the 1 index. So now you can choose on either data frame whose key column to use, either the right or the left. If you want to use both of them, you can create a union of both keys. The way to do that is, again, just pass the merge method. We'll call dframe1, dframe2, and then we'll label it on that key. And then if we want to use both the union of the keys, we can label the method how as an outer argument. Okay, and now we've been able to pass the union of both the keys. So the x's, the z's, the y's, and the q's. Since dataset 2 didn't have any values for x, it's still going to show null values there. So now we're going to learn how to do a many-to-many merge. And for those of you familiar with SQL, those terms will be familiar to you. So let's go ahead and make another pair of data frames. Let's see, we're going to have dframe3, and let's go ahead and pass a dictionary. We'll say key, and we're just going to input then a bunch of letters again. Let's say XX, Y, and then ZZ. And then that's one column. Let's go ahead and set up the dataset column. This is dataset 3. And we'll just set that up to be a range of 6 points, since we have 1, 2, 3, 4, 5, 6 in the key. So we'll set that to be a range of 6. Alt enter. Then let's make another data frame. We'll call it dframe4. Let's go ahead and see what we can do here. Let's pass a dictionary. We'll label one of the columns key. And now I'm going to pass a shorter list. I'll say Y, Y, XX, Z. And let's make a fourth data set, and we'll set the values as a range of 5, since our key is 5 long. Now I need to use parentheses there. 5 long, and let me get a curly bracket to finish that dictionary input. Okay, so let's take a look at what data frame 3 looks like. Okay, and then let's take a look at data frame 4 as well. So these are the two data frames we're going to be using. Look at how their keys are. Got X, 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 Y, Z, Z on the third data frame, and Y, Y, X, X, Z on the fourth data frame. Cool. So let's go ahead and merge them, see what happens. PD merge, dframe 3, dframe 4. See what we get. Alright, so now the data sets are merged based on both their index and where they matched on that key column. So you can see dataset 3 and dataset 4, those values are now on the same row if they were able to get matched up by that key and by that index. Now if you notice something, the values are a little different, if you might have noticed. So for instance, let's look at dataset 3 on 0 and dataset 4 on 0, and they were both 0 on the key Y. Let's look where dataset had the key of Z. So you have dataset 4 and dataset 3, key of Z. Dataset 4 was 4 on that. Dataset 3 was 5 on that. And so now you can see they've been matched up there. You also had a 4 on dataset 3, so it got matched up. And dataset 4, it pulled that same value to make that match on the Z. So now you don't have a null value there. Okay. So we can also merge with multiple keys. So I'm going to make another data frame. So I'll say df left equals data frame key 1 and let's go ahead and pass some city initials as those values. Then let's go ahead and make a second key, and we're just going to pass let's just say 1 2. Let's just say 1 2 1. And then I'll make one last entry into this dictionary. I'll say the data itself, set that equal to 10, 20, 30. Okay, and then let me just format this a bit so it's easier to read for you guys. So I have my key 1, SFSFLA, my key 2, 1 2 1, and then my data is 10, 20, 30. Let's make another data frame. We'll call it df right. We'll pass another dictionary here. We'll say key 1. We'll call it SFSF LALA. Let's make another key 2. And then we'll just make it 1 1. Let's go ahead and make it 1 2 after that. And then lastly, we'll have write data. And we'll make the write data equal to 40, 50, 60, 70. Okay, so let's go ahead and take a look at those data frames separately before we merge them. So data frame left, we made a key 1 and a key 2 column. Key 1 is the cities, key 2 is just the 1, 2, and 1 names, and then we have left data, which is 10, 20, 30. df right, we have key 1, again city initials, key 2, 1112, and then write data 40, 50, 60, 70. So let's see what happens if we merge them. So if we're going to merge on multiple keys, I can input df left, my write data frame, and then I'm going to try to merge them on both key 1 and key 2. So let's see what happens. I can input a list for multiple keys or column names. So I'm going to merge them on key 1, key 2, and I'm going to say outer, so it does the union of those. And let's see what happens. So now I have key 1 and key 2, and now the left data and the right data have been merged to match up together by their keys. Right data had no data for SF2. So if we look at that right data, there is no SF2, there's only SF1. So it's going to give you a null for that data there. So using the above, you can check multiple data sets for multiple key combinations. So for instance, if you wanted to know, what was the left data set have for LA1? So you can then look up LA1 and check that the left data set had 30 and that the right data set had 60. Okay. So now you're going to note that the left and right data frames have overlapping key names, key 1 and key 2. So Pandas can automatically add a suffix to them. And we can do that by just saying pd merge df left, df right, and let's just do it on one key this time. We'll say on key 1. So now we've merged those data frames on key 1. So if you notice, since I only merged it on one key and the rest of the data frame still had multiple columns, and they were named the same thing, so they each had a column named key 2, Pandas automatically added a suffix to it. So it said for the left data frame 1, it gave it a suffix of _x, and for the right data frame 1, it gave it a suffix of _y. So if you accidentally weren't paying attention, or you wanted to do this on purpose, and you just only wanted to merge by one column, and they happen to have two columns that were named the same, Pandas will automatically keep them separated for you. Okay. Since there's the suffix, if you didn't want it to be automatic and you wanted to specify what that suffix was, you could merge it yourself. So df left, df right. Let's merge it on key 1. And then we can also pass the argument suffix, sorry. And we can decide what we want that suffix to be. So we can say lefty for the first one, and then _righty for the second one. So instead of automatically saying _x _y, we can say _lefty _righty. And let's see what happens when we do that. And there you go. Since key 2s were in both of them, now you can choose a suffix _lefty _righty, or whatever you want to decide to put there. So there's a ton of info on merge parameters in the documentation. So if you want to check more stuff, some more specific things, you can check out the documentation. The link is in the IPython notebook on the GitHub link for the notebook viewer. If you want, we can just check this out real quick on merge. So let's go ahead and check that out. So like I said, we have the how method. We can label the indexes, which indexes we want to use, and choose the suffix to use if there's the same name index or column on both of them. Alright, So that's the basics of merging. You just do pd.merge, put in your two data frames, define which key you want to merge it on, define how you want to merge it, either left, right, or by the union of both keys, and then you can also choose a suffix for each key to be merged. So that's all you really need to know as far as right now. Next up, we're going to learn how to merge on the index and not by the columns. I'll see you there. Okay guys, welcome to lecture 30. In this lecture we'll be learning how to merge on index. So previous lecture we saw merging and how we used columns to do that and keys. Now we're going to use indexes to do that same thing. So import the usual, pandas as PD. From pandas import series and data frame, and import NumPy as NP. Okay, so let's go ahead and make two data frames. I'll make a data frame called df_left, and we'll construct it using a dictionary. So I'll set a column to be called key, and I'll pass a list. So let's just go with x, y, z, then x, y. Alright, and then next column we'll say it's, we'll call it data. Sorry, one of my keys was sticking. Okay. We'll call it data. And we'll pass a list there as well. Actually, we won't. We'll just call it a range. We'll say we want 5 points. That's dr left, or data frame left. Let's go ahead and take a look at what that looks like. All right. Then we have a key column, x, y, z, x, y, our data column. And then let's make a data frame right, df_right. Construct it in a similar manner. We'll say, we'll pass the dictionary. Let's call one column group data, and it'll be a list. Just 10 and 20 will be the values, and that's it actually. And then we'll give it an index, and the index will be x and y. So notice how in this first part for the data frame I have my dictionary, and then the second part I label my index. And then just take a quick look at what that looks like. So I have x and y indexed, and then I have my group data, which is just 10 and 20. So we'll merge, and we'll use the key for the left data frame, and then the index for the right. So let me show you what I'm talking about. pd.merge. We'll put in the left data frame we want to merge with the right data frame. And now I can pass left on, and we'll say key. So the left data frame will merge on the key, and then I'll say right index equal to true. So let's go ahead and take a look at what happens there. So if you noticed, we were able to use the index for the right and the key for the left data frame. So key for left data frame, x, y, z, x, y. We use that in combination with the data from this group data. So now every x in group data was a 10. So the keys from the left data frame, x, y, z, x, y, since there was 2 x's and 2 y's, in the merging we have 2 x's and 2 y's, but we're using the group data 10, 10, 20, 20. And then we also have the data column from our left data frame. So if you want, you can go ahead and mess around with different left ons and with the right index true and false. See if you can predict the data frames that come out, and that way you'll know if you understood it or not. Let's try a little something different. So how about using a hierarchy index with merging? So I'll make another data frame. I'll call it df underscore left HR, 'cause it's going to have an index hierarchy. I'll construct it using data frame. And let's go ahead and make a dictionary. We'll call this key1. And I'll use city values in this case, or city initials, I should say. SF, SF, and then we'll have the last two be LA, LA. And then next entry in that dictionary will be key2. We'll leave values, how about 10, 20, 20, 30. And we'll keep dataset. And this column will just say np dot arrange 5. And I'm going to add a point here to let it know that it's a floating point number. And it looks like I forgot a comma here and a comma there. Alright, excellent. Let's make sure that was all inputted correctly. I accidentally put one extra R. And whoops, what did I mess up? Arrays must be all the same length. Do I have them all the same length? Let's see. Key 1 was 5, key 2, I accidentally have it. So let me add another number there. So now that should be 5 points. Okay. And let's just take a look at what we got. Nice. So our data set is just 0 through 4, so 5 points there. Key 1 are the cities we put in. Key 2 are those numbers we put in, 10, 20, 30, 20, 30. Now let's make another data frame. We'll call it df right HR. This data frame, I'm just going to say np.arrange 10. I'm going to reshape that into a matrix as we've done in the past. I'll make it a 5 by 2. So those will be my data points. Then I'll set up my index. My index is going to be, so I'm going to have an index hierarchy here. So that means I'm going to pass a list of lists. So I'll have LA, whoops, not Alabama, LA, SF, 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 and then since this is an index hierarchy, we'll make another one and we'll call it, let's just have it be some numbers, 20, 10, 10, 10, 20. And since we have our index, we need to make some columns. And we should have the columns equal to, I'm just going to call them call 1 and then call 2. And let me put an underscore so it's a little more readable. Okay, let me just look over this to make sure we wrote it all in right. Our data is np.arrange 10.reshape 5.2. And then we have our index, which is 2 lists, LA, LA, SF, SF, SF. And then we have 20, 10, 10, 10, 20. And then we have our columns. So let's see if we got that right. Looks like I should have had a apostrophe there. Okay, now let's try it out. Okay, cool. And let's check out the data frame. All right, so we have a index hierarchy here. So we have the cities, and then their separate values, and then our 2 data sets of column 1, column 2, with the random number or the arranged numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 from np arrange 10 reshape 5, 2. Okie dokie. So we can merge the left by using keys and the right by its index again. So let's go ahead and see what that looks like when we do it with index hierarchy. So we have df left HR, and then the data frame on the right, which call HR as well. I'll say merge the left on key 1, key 2, and then the right index will say true, so it merges the right by its index. Let's go ahead and see what we got. Okay, so if we take a quick gander at that first left data frame, we have our data set and then key 1, key 2, and then on the right we had LASF, its sub-index, the 10s and 20s, and then the 2 columns. So now when we merge them, we have our data set values merged by the key 1 and key 2, and then the right index. So it kept this SF, LA, and the 10s and 20s. Nice. So our data is now merged and formatted. If you don't want to put in so many arguments, Pandas does have another method of joining stuff, or merging stuff I should say, and you can just do that by using the method join. So join is what we're actually going to be using most of the time. So let's go ahead and take a look at those original data frames, df left and df right. So df left was 0, 1, 2, 3, 4, the key was x, y, z, x, y, df right was x, y, 10, 20, and when you said left, join it with the right, you got the data and keys lined up, but group data, since it didn't line up with any of the indexes, it left it as straight nulls. And you can pass the same arguments through join as we were doing through merge to get specific columns or indexes that you want. Okay, so we'll probably be using join more than merge in most of the lectures in this course, but it's important to know how merge works in order to understand how join works. So go ahead and mess around with inputting different keys and indexes, right index set to false, or choose different keys to merge on, just to make sure you get a good understanding of what exactly is being merged and how it's being merged. So that's how you merge on index. Next up, we'll learn about the concatenate function. So I'll go ahead and end this lecture here, and I'll see you at the next lecture. Hey guys, welcome to lecture 31. This will be on concatenate. So we're going to be able to join data frames and matrices together, almost like a sandwich, if you will. So we're going to import the usual. NumPy is NP, Pandas is PD, and from Pandas we'll import series and data frame. So first let's learn about concatenate in NumPy. So I'll create a matrix. I'll just call it ARR1, and I'll construct it using np.arrange. I'll get 9 points, and then I'll reshape it into a 3x3 matrix, and I'll type it so I can see it. Okay, perfect. So we have our 3x3 of 9 points. So we can concatenate along axis 1. So to do that, we just pass np.concatenate, and then the list of matrices or arrays you want to concatenate. So for instance, I can just get 2 copies of that matrix and specify axis 1. Let's see what happens. So now they've been sandwiched together, so I have a 3x6, and you can kind of see how they were attached. So 0, 1, 2, 3, 4, 6, 7, 8, and then a repeat of the same matrix. If you want to do it on a different axis, you totally can. You just got to specify. So for instance, let's say we wanted top to bottom. We could again just get 2 copies of those arrays, and then specify axis equals 0. And now you'll see we have done it from top to bottom. Cool. So that's how to concatenate in NumPy. So how about we try it in Pandas now? So we'll start off by making some series. So SER1, we'll just call it, we'll make a series with the points 0, 1, 2, and we'll set its index to be T, U, V. And we'll make another index. We'll say series, and this one we'll just give it 2 points, 2 values, and then its index will only be 2 values as well. We'll just choose some other letters. Let's say X and Y, and then let's just see how they ran correctly. Cool. Let's see them both real quick. So there's our first series, and there's our second one. So 0, 1, 2, TUV, and the second one is 3, 4, XY. Awesome. So how do we concatenate in Pandas? We can do that by saying pd.concat. So that's the method you can call, and then similar to NumPy, you just give the 2 series you want to concatenate, and it will add them it will concatenate them together. So now we have 0, 1, 2, 3, 4, and the letter in this index for both of them. You can also specify which axis. So we can say concat, pd.concat. Again, we'll pass in those 2 series. And we can specify, for instance, axis 1. And if I do this, it will produce a data frame. So it'll create an index 0 and 1 for the column names, and then it'll create a data frame because you have some null information. So your second series didn't have TUV information, and your first series didn't have XY information. So it fills those with a null value. But now you have a whole data frame from concatenate of those 2 series. Awesome. So let's say we wanted to add markers or keys to the concat result. So we could do this by using index hierarchy, which we've learned about in the past. So I can call concat on the 2 series, SER1, SER2, and I can set keys for them. So I can call one, let's say cat1, and I can call the other one cat2. Let me make sure those are strings. Alright, and let's see what happens if I do that. So now it was able to concatenate both of the series, but it's also labeled them through a hierarchical index, so I can remember which series was which. So cat1 is my first series, and now cat2 is the higher index of my second series. And then lastly, everything that we've done works really similarly in data frames, not just series. So let's go ahead and make 2 data frames. We'll make dframe1, call it data frame, and we'll call np.random.randn since we didn't import it specifically. We'll make a 4x3 random matrix, and then we'll set the columns equal to, let's just say x, y, z. And then we'll make a dframe2, and we'll start it from data frame. Again, we'll say randn, and in this case, let's make a 3x3 random matrix and set the columns equal to y, q, and x. So now that we've created those data frames, let's go ahead and take a quick look at each one so we know what we're dealing with. That's what our data frame 1 looks like. That's what our data frame 2 looks like. So they both have x and y columns. One of them has a z, the other one doesn't. The second one has a q, the first one does not. So let's see what happens when we run them through concat. So we'll say pd.concat to concatenate them, and we'll run them through a list, dframe1, dframe2, see what the result is. So as you'd expect, it binds them together, and you're going to get null values for where each data frame didn't have any values under the columns of the other data frame. So data frame 1 didn't have any q values, so it'll leave them all as none. Data frame 2 didn't have any z values, so it puts a null there. If we don't care, so you'll notice if we don't care about the index information, we can get rid of it. So if we look at the concat result on the index specifically, you'll see 0, 1, 2, 3, and then again the index 0, 1, 2. So it kept the index information when you use concatenate on the two data frames. If you didn't care about that index information and just wanted it to keep going, for instance 0, 1, 2, 3, 4, 5, 6, you can make that happen. You can just have it ignore the index. So in order to do that, we can call concat, again on dframe 1, dframe 2. And I can pass the argument ignore underscore index, set it to true, and it should ignore that index and give us a continuous index now. And that's what we got. So now we have 0, 1, 2, 3, 4, 5, 6. So that's about it as far as using concatenate. If you want to get a little more specific, there's always more information in documentation. So there's a link in the IPython notebook, and I'll also write it down here. I'll copy and paste it from the IPython notebooks that we have in the viewer, and I'll leave it there for you. So to go, just a quick overview, using concatenate in NumPy, it's np.concatenate, and then in Pandas, it's pd.concat, and it works on both series and data frames. And data frames, Panda will take care of index values and null values for you automatically. And you can ignore the index to get a continuous index if you wish to do so. Alright, so you can check out the documentation if you want even more detailed information. But until then, we'll go ahead and head off to lecture 32, and we'll learn about combining data frames with overlapping indexes. Okay, I'll see you there. Hey guys, welcome to lecture 32. In this lecture, we're going to learn how to combine data frames. Alright, let's get started. So we'll import the usual. Import NumPy as NP, import Pandas as PD, and then from Pandas, import series and data frame. Let's go ahead and take a look. Okay. Let's make some series to work with. So SCR1 series. Let's go ahead and pass a list of values. I'm going to put some null values in there so we can see how Pandas deals with that. So I have a total of 6 values there, and then let's give it an index, and we'll just make that index Q, R, S, whoops, T, U, and V. Alright, and then we'll check that out. Okay. And then let's go ahead and make another series. This series, we're just going to get some numbers, so we'll say np.arrange. And to make it the same length as series 1, we'll just do len, the length function on our first series. And then we'll specify, pass the argument dtype, and that will specify the type of object. So we'll say np float 64 to specify that they're floating numbers. And then index, we'll just we'll copy and paste the same index from before. So let's go ahead and do that. Okay. And then let's type to make sure everything worked out correctly. Alright, so we have 0, 1, 2, 3, 4, 5, and then QRSTUV. Awesome. So now that we have those two series, let's get a series where the value of series 1 is chosen if series 2 is null. Otherwise, we'll let the value be series 1. So to show you how to create that kind of series, I'll call the series command, and I'm going to use NumPy's where method. So I'm going to say np.where. So I'll say pd.is null. So where pandas is null, and we'll put in series 1 as the argument. Select a value from series 2. Then we'll say otherwise, select a value from series 1. And then we'll set the index to equal the index of the first series. So let's just look at this before we click enter here. We're using NumPy's where, so we're saying np.where, and then wherever series 1 is null, put in the series 2 value. And if not, then just put in series 1. Okay, so let's see what we got then. So now I have QRSTUV 214365. So if we look at the null values for series 1, it was on the R, the T, and the V. And now if we look at the R, the T, and the V, those values had now been obtained from the second series, SER2. So that's how you can use NumPy's where command to do a little bit of logic. Just take a moment to make sure you really understood what happened here with asking for the null and then choosing SER2, otherwise choosing SER1. We can do the exact same thing using the combine first method, which is built into Pandas. So I showed you the long way, now I'll show you the shortcut. So the shortcut you can say is just combine underscore first SER2. So this will do the exact same thing as that where command. It'll say take series 1, combine it with series 2, but if there's a null value there, then use the value from series 2. And we get the exact same result. So that's kind of the shortcut method to this longer version using NumPy's .where method. So that's how it works on series. Let's go ahead and take a look at how it works on data frames. So we'll make a D frame, and we'll call it D frame odds. And then we'll pass a dictionary into the data frame. So we'll say X, and we'll give it a list. We're going to say 1, we'll put in a null value, and in fact what I'll do, since we're going to be using a lot of null values here, I'll set nan equal to np.nan, so I don't have to type as much. Going back to that dictionary, we'll go 1 dot, put in a null, 3, the dots are to signify indicate the floating numbers, and then another nan value. And then we'll have another null value, a 5, a null value, and a 7. And then the last entry will be z, so we have x, y, z. And then we'll make it have a null value, a 9, a null value, and 11. So this data frame only has odd numbers. Let's go ahead and make sure it took. Okay, and now let's make a data frame called data frame underscore evens. And we'll pass another dictionary through that. And in this case, we'll just say X. We'll set it equal to 2. Let's say 4. I'll put in a null value, 6, 8. And then we'll make Y with its entries list be a null value, 10, 12, 14 and let's just say 16. Okay, and we'll skip the z on that one. Let's make sure that took. All right, so let's go ahead and show them. We got dframe odds. All right, there's our data frame, x, y, z columns with the odd values. And then let's get the evens one. Okay, x, y columns, only even values, a couple of null values spattered throughout. So let's combine them now. So we'll say dframe underscore odds, and we're going to do the exact same thing we did on the series. So we'll say combine underscore first, and then we'll pass dframe evens object through it. So take a minute to think what the result should be of this. So it's going to take dframe odds, and where there's a null value, it will pass dframe evens. So let's just imagine what that first column should look like. First column, x, we have a 1 null, 3 null. So that means if we combine it, we should get a 1. We'll take a null, so then if we look down here at dframe evens, that should be a 4. The 2, we have a value, so that one's good. On the third index, we have a null, so that will be 6. And then the fourth one doesn't exist on dframe odds, so it'll input the dframe evens. So your first column, after issuing this command, should be 1, 4, 3, 6, 8. And it will carry the same kind of operations on the y and z columns. So let's go ahead and see if we were right. Yeah, so the x column, like we expected, 1, 4, 3, 6, 8. And then you have the y and z columns. If there were null values on both of them, then we'll keep the null values in the combined first result. You can go ahead and make your own data frames and pass different combinations using the combine underscore first method, just to make sure you really understand how it's working. So just to overview, you could use np.where with the isNull logic and specify the index, but the shortcut method that Pandas has built in is combine underscore first. And you can do that on data frames as well. So that's how you combine data frames. Next up, we'll learn about reshaping. Hey guys, welcome to lecture 33. This lecture is going to be on reshaping. So we'll import the usual as always, NumPy as NP, import Pandas as PD, and then from Pandas I'm going to import series and data frame. Alright, so first we're going to see how the stack and unstack methods work. In order to do that, I'm going to make a data frame. So I'll say dframe1 is equal to data frame, and we'll create this data frame using NumPy arrange. We'll get 8 points, and then I'm going to reshape them as a 2x4 matrix. And then we'll set the index equal to panda index pd.index, and we'll have the list just be, how about some cities, and I'm going to name this index equal to city. The reason I passed the index as pd.index instead of just saying index equals this list of LASF is because by passing the pd.index, I'm also able to name it at the same time. And then using columns, I can do the same thing. I can say columns equals pd.index, and I can pass A, B, C, D. And I'm going to set this name equal to just letter, since they're letters. And then we'll show it. Hopefully there are no typos. Okay, awesome. So we have the columns, our letters A, B, C, D, and the index city name, LA and SF, and then we have 0 through 7, 8 points on a 2x4 matrix. So how can we use stack? So we can use stack to pivot the columns into the rows. So to show you what I mean, I'll make a new data frame. I'll call it data frame underscore st for stacked. And I'm going to set this equal to data frame 1, and I'm going to call the stack method on it. And let's see how that goes. Cool. So now in a sense we've pivoted it, and now we have the city and a sub-index of the letters. If we want to rearrange it back into a data frame, we can do that. We can just take dframe st that was pivoted, and I can say unstack to turn it back into a data frame. We can also choose which name to unstack by. So instead of unstacking that way, I could also say dframe underscore st. I can call the unstack method on it and specify that it should be unstacked by the letter. Let's see what happens there. The exact same thing, since that was the default unstack. What if I unstacked by the city though? Let's check out what happens. If I unstack by the city, then it's basically reversed, and now you have the cities being the columns and letter is now your index for that data frame. So you can specify and unstack what you want the columns and index to be. So let's see how stack and unstack handle null values. So in order to do that, I'm going to make two series. I'll call the first one ser1. Set it equal to series. Let's say 0, 1, 2. And then I'll make my index equal to just some letters. Q, let's just say XY. I'll make another series, ser2, equal to 4, 5, 6. And then we'll have my index be X, Y, and Z, for instance. Okay, let's make sure that worked. Cool, so I have my two series. So I'm going to use, I'll set my D frame so I can make a data frame. I'm going to use concat, remember from concatenate. I will use that to make the data frame out of the two series. So we have a little review of what we've done before. And I'll set the keys equal to alpha and beta. And then we'll just check out what that data frame looks like. Awesome. So it's not quite a data frame yet. It's just two series that have been pushed together with concatenate. If I want to make it into a data frame, I'll have to unstack it. So I'll say dframe unstack, and now it shows up as a data frame. Cool. So we have null values. How do I get rid of those? Well, using pandas, if we have our dframe unstack, and let's say I stacked it again, that will automatically filter out the null values. So let's make sure of that. Cool. So again, just like before, the null values have been filtered out. So you get null values when you unstack into a data frame, but if you stack it back into that combination of those two series, you don't get those null values anymore. If we don't want to do this and we actually want to keep these null values from the data frame, we can do that as well. So let's set our data frame to equal dframe.unstack. So now if I call my data frame, I have this permanent data frame with two null values there at Q beta and beta Z. or I mean, sorry, alpha z. And now, if I were to call stack on this normally, it would get rid of the null values, but if I wanted to keep them there, I could call stack and pass the argument drop NA equal to false. And now I've kept those NA values, the alpha z and the beta q. So that's about it for reshaping. It's mainly just being able to use the unstack and the stack. And next up, we'll learn more about pivoting data frames in a similar fashion. All right, I'll see you there. Hey guys, welcome to lecture 34. In this lecture, we're going to be going over pivoting and pivot tables. So we're going to import NumPy as NP, Pandas as PD, and then from Pandas, we're going to import series and data frames. So the important thing about pivot tables, they can really depend on what information you're actually looking for. So if you're not familiar with pivot tables in general, we can just come over here to the pivot table Wikipedia page. So a lot of times for databases, for data entry and storage, your data is going to appear in a flat table. So if we look at this first table example, you have multiple regions, east and west, but then you have multiple entries for each region. So for instance, you have the boy and girl subset of the east and west regions. And what you want to first start off with when you're creating a pivot table is what am I seeking? So what information do I want to know? And that's going to be one of the most important questions you can ask yourself when analyzing data, or just data science in general, is what information do you actually want to know? So in this example, they wanted to know how many units did we sell in each region for every ship date. And so they create this pivot table, and this pivot table will basically sum up all the shipment units for each date, depending on the region. So this kind of pivot table can really depend on what information you want. So you could have also asked, how many units did you sell to boys versus girls on particular dates? What was the average price based on the regions, etc., etc. So in order to kind of just see how to do pivot tables in Pandas, we're going to create some data to play with. This data I'm going to get from using the Pandas testing utility. And the way I'm going to do that is I'm just going to copy and paste from one of the IPython notebooks on the GitHub. So it's really outside the course to know, it's outside the course's frame to know how I made this data frame to work with. We're just using the Pandas testing utility, but it's outside the scope of the course to need to know how I created this table. We're just basically creating an unpivot function, which gives us a bit of a sloppy, flat data table to work with. So let's go ahead and look at what the frame looks like. Cool. So I have multiple instances of the variables A, B, and C, different values for each one, and then different dates for each one as well. So again, don't worry about how I made this data frame. It's just using the testing utility, but you won't need to know that for this course. It's just a convenient way to make data frames to test certain things. If you want, you can look in more on the documentation about utility testing, but this lecture is just to show you if you had a certain data frame and you wanted to know a certain thing, how could you make the pivot table for it? So this data frame, we can think about this as stacked. So note how there's multiple variables and values for the dates. And let's pivot the data. So let's say we wanted to know the variables, let's say A, B, and C, and D for particular dates. What were their values? So we can go ahead and say dframe underscore PIV, so our pivoted data frame. In order to pivot it, we just call the pivot method on that data frame. And then what we pass is the row and column indexes, and then optionally a fill value. So I'm going to want my rows to be the date, so I'll pass that first. I'm going to want my columns to be the variable, and I'm going to want my value, my fill value, to just be the values. So that's how you do a pivot table. You decide what you want for the rows, the columns, and what you want the fill value to be. So I can take this stack data frame and basically unstack it and pivot it. So let's go ahead and do that. And then let's see what it looks like. Alt Enter. Alright, cool. So now I've pivoted this table and I can see some of the values for A, B, C, and D depending on the date. So this is just a general introduction to pivoting and pivot tables. It's going to really depend on what specific information you want to know and how you want to present it. But it's good to know that you can easily pivot data frames just calling the pivot method and then deciding what you want the row, column, and values to be. It's pretty much that simple, and it's really going to depend on what your flat data table, your stack data table looks like and what information you want to come out with it. Okay, so that's about it for pivoting. Again, you don't have to worry about how I made that data frame. It's just using some testing utility that we won't be using in the future. And next up, we're going to learn about how to find duplicates in data frames, so if you have duplicate values. Okay. Hey guys, welcome to lecture 35. This is going to be about duplicates in data frames. Alright, so import the usual. NumPy is NP, Pandas is PD, and then from Pandas we'll import series and data frame. Alright, so let's go ahead and make a data frame. We'll call it dframe, and we're going to make it with duplicates on purpose. So we'll have data frame. We're going to pass a dictionary, so we'll just say key 1. And then we'll have it be, let's say, we'll pass A, and we'll have 2 instances of A. And then we'll also add 3 instances of B. How about that? Whoops, that should be a comma. And then we'll make a second key, and we'll pass just a list, which is kind of the reverse. So this is different ways of making it a list key. So this instance I just multiplied A by 2 to get AA, and then I added 3 B's on top of that. Here I just wrote out manually 2, 2, 2, 3, 3, 3. Okay, and then let's go ahead and show that data frame. Nice, so we have key 1, key 2, letter AA, and then BBB, and then key 1 and key 2 and their values that match up. So how can we find duplicates? It's actually really easy with Pandas. We can pass the term duplicated with no additional arguments, and it'll tell us if rows are duplicates. So for instance, that first row, it's going to yield you a false since it hasn't seen a duplicate yet, A2. And then the second row, the index 1 row, it's going to say that it is duplicated, true, because its previous row was also key 1A, key 2, 2. And if we look at the very last row, B3, it's also true duplicated because it's the second instance of the B and 3 row. So that's how you can find duplicates. Let's say you wanted to get rid of those duplicates. You can drop them, and you can just simply pass the method drop underscore duplicates with no additional argument, and it'll get rid of any duplicates it found. So now we only have those false values from before, the 0 index row, and then the second and third index row, 0, 2, 3, and now we have those rows. So we were able to drop the duplicates. You can also filter out which duplicates to drop by a single column. The way to do that is, again, just say dframe underscore drop duplicates, and you can pass the column name that you want to drop from. So now I dropped duplicates specifically from the key 1 column, so that means anything that was duplicated as far as the letters has now been dropped. So anything that had an additional A after the first one or an additional B after the first B showed up has been dropped. So you only end up being left with the 0 and 2 indexed rows. So that makes sense. Let's go ahead and show the original dframe. Alright. By default, the first value was taken for the duplicates, but we can also take the last value instead. To show you what I mean by that, we can say dframe, let's bring this to center, dframe drop underscore duplicates. We'll pass it on key 1. So if you notice last time, we just took the first instance and then dropped later duplicates. Let's say instead of doing that, we wanted to take the very last duplicate. So we can do that by saying, passing the argument take underscore last equals true. So what do we expect to happen in this case? So that means the very last time, since we're calling it by key 1, that it sees the duplicate, it'll keep it. So before we press enter, let's go ahead and try to imagine what's the result going to be. If we look at key 1, the last time an A shows up is in index 1, so it's going to keep that row. And then if we keep going down key 1, the last time a duplicate of B shows up is at the 4th indexed row, so we should expect rows 1 and 4 to be kept, since we're taking the last, setting equal to true. Let's see if that works. And that's what we got. We got the 1st and 4th indexed rows. Awesome. So that's about it for finding duplicates. It's pretty straightforward. You just pass the method either duplicated to find the Boolean value if they're duplicates or not, and you can just say drop underscore duplicates, and you can pass specific columns as an argument. And you can also pass take last true if you want to get the last duplicate value. That's about it for duplicates. Next up, we're going to learn about mapping. I'll see you there. Hey guys, welcome to lecture 36, and this lecture will be on mapping. So we're going to import the usual, import NumPy as NP, import Pandas as PD, and then from Pandas import series data frame. Alright, so mapping is a great way to add columns to data frames, and I'll show you what I mean by that in a second. So let's create a data frame to work with. We'll say dframe equals, let's make a data frame, and then we're going to say, let's have it be a column for city. We'll pass a dictionary, and then this key will have, let's go ahead, I'm just going to get some information off Wikipedia. These are some of the highest elevation cities in the United States. So we got Alma, Bryan Head, Fox Park. And let's create another entry, another key in that dictionary. We'll create altitude. And here's the altitude for each of these cities. 3,000. And this is in meters, I believe, 2762. Alright. And then let's go ahead and show that data frame. Cool. So now you have a data frame that has the altitude of the cities and the city names themselves. So let's say you wanted to add a column to this data frame, but you wanted to add a column for each state that the city is in. So you can use mapping to map the column so that your states match and map onto your cities. So I'll show you what I mean by that. So let's go ahead and create a dictionary. We'll say state underscore map equals curly brackets for the dictionary. So Alma is in Colorado. Bryan Head is in Utah. And Fox Park is in Wyoming. Alright, so now we have our dictionary state map, and then let's go ahead and we'll call dframe we'll create a column, say dframe state equals dframe, and this is how we're going to map it. We're going to say call the city column and then pass the method .map, and what we're going to map to it is that dictionary we made called state map. So what we're doing right now is we're creating a new column called state, and we're calling the map method onto the city column. So now wherever these cities match up in our state map dictionary, it'll add the state into a state column. So we'll do that. Now let's see what our data frame looks like by calling dframe. And so now we have an altitude, the city, and the state. And the states have been correctly matched with their cities. Cool. So mapping is a great way to do element-wise transformations and other data cleaning operations. There's lots of different ways you can use this, but as far as the overall method, the simplest way is just creating or modifying a new column and then just using the .map method to pass a dictionary object and map it to a column that already exists in your data frame. Okay, so that's it for mapping. Next up, we'll learn how to replace values. I'll see you there. Hey guys, welcome to lecture 37, and this will be just a quick lecture on how to use replace with your data frames. So, copy and paste, or just type out the normal imports, which is import NumPy as MP, import Pandas as PD, and then from Pandas, import series and data frame. Alright, awesome. So let's go ahead and make a series. We'll call it SCR1, and the series we'll just build it using a list. So I'm just going to go 1, 2, 3, 4, and then again 1, 2, 3, 4, and then let's go ahead and show that series. There we go. So we have it indexed, and it's 1, 2, 3, 4, 1, 2, 3, 4. So using replace, we can select which value we want to replace with the new value, and a new value to replace it with. So for instance, the way this works is you call the replace method, which is just .replace, and then you select the value you want to replace, and then the new value you want in its place. So for instance, I can say that I want every one value in that series to be replaced by a null value. Let's go ahead and see if that worked. Awesome. So now every value that was 1 has been replaced with a null. You can also input lists into the replace method to show you how those work. Let's say I want to replace the 1s and 4s, and I want to replace them with 100 and 400 respectively. So the lists need to match up so that every value of your first list will be replaced by the value in your second list. So every 1 will be replaced by 100, and every 4 will be replaced by 400. So let's go ahead and pass that. Cool. So that worked, and that's how you can do multiple replaces at once. And then the last thing, you can also input a dictionary. So for instance, I have my scr1.replace, and I can pass a dictionary so that in a similar manner every 4 gets replaced by a null value. So you can just input a key and a value to be replaced. So let's go ahead and see how that works. And so now every 4 value was replaced by a null value. So that's it for replace. Just a quick overview. You can just call .replace onto your series, and then you call the value you want to replace and then the value you want to replace it with. You can also pass lists to do multiple values at once, and you can also pass dictionaries in a similar manner. You replace the key with its value. So that's it for replace. Up next, we're going to learn about renaming an access index. I'll see you there. Hey guys, welcome to lecture 38. This lecture will be on renaming indexes. I'll call it rename index. And so we're going to import the usual. We're going to import NumPy as NP, import Pandas as PD, and then from Pandas we'll import series data frame. Alright, so now that we've done that, let's go ahead and make a data frame. We'll say dframe equals data frame. Let's go ahead and just get some numbers, a number matrix to fill out some values. So we'll say np.arrange, and then I'll reshape this array into a 3x4 matrix. After that, I'll just set my index equal to some city initials. And then I'll set the columns equal to just some letter values. So we'll say A, B, C, D. Okay, and now we have our data frame. So just like a series, access indexes can also map. So we can use map to lowercase the city's initials. So how can I do that? I'll show you. So for instance, we can say dframe.index, and then I'll call a map on the index, and using that map I'll input the command str.lower, so this will lowercase that index, and so now my array is the lowercase of each of those cities' names, or initials I should say. If I want to assign this to the actual index, I can use dframe.index equal to the value I wrote above, index.map, and then str.lower to lowercase everything in that index. And now if I look at my dframe, the effect will be permanent. Cool. I can also use rename if I want to create a transformed version without modifying the original version. So if I want to do that, I could say dframe.rename, and this is where we're going to learn more about renaming indexes, and then I'll say index equals str title. That's the way to make it capitalized. And then I'll set my columns equal to str lower. So I'll lowercase the column letters. Let's see if that works. And so now using title, it's capitalized the first letter of the row index values, NYLASF, and then it's lowercase the column names. So I can use rename to create the transformed version of that data frame. I can also use rename to insert dictionaries providing new values. So I can say dframe.rename, and then I can pass index equal to, let's say, a dictionary, NY, and I'll call it New York. Get the full name. Then I can also pass columns equal to A, and then I can rename that as alpha. So what I'm doing here is I'm passing dictionaries with the arguments index and columns using the rename method. So that's going to rename my index and my column. So let's go ahead and see what happens. So as we expected, now NY has been renamed to New York, and that A has been renamed to Alpha. Cool. So you can actually edit the dataset in place. The way to do that is I can say dframe. Well, to show you what I mean first, let's just take a look at the original data frame. So those effects weren't permanent. If I want to make them permanent, I can say dframe.rename, input the original stuff we just did, New York, finishes that dictionary, and then since I want to make an edit to the data set in place, I can just set in place argument equal to true. And now when I call my dframe, those effects are permanent. So it actually edited the data frame in place. So that's about it for renaming indexes. So just to go over it, you can map things to an index to edit it, but you can also just use rename, and you can rename and input arguments index, either a dictionary for renaming, or you can pass arguments or methods onto the index and columns themselves, such as lowering or uppercasing the column or index values. Hey guys, welcome to lecture 39, and in this lecture we'll learn about binning. As always, we'll import the usual, pandas as PD, and from pandas we'll import series and data frame. Okay, so we'll learn about binning right now. To start off with, let's go ahead and make a list. We'll just call it years, and I'm going to just go 1990, let's see, 1990, 1991, 1992, and let's skip ahead to 2008, 2012, 2015, and then we'll go back so it's not in order, 1987, 1969, 2013, 2008, and 1999. Alright, so now I have kind of just a random list of years, and then I'm going to make another list called decade underscore bins. So I'm going to be using this list to separate these years by decade. And so for this list, it's going to be pretty simple. It's just going to be 1960, 1970, just all the decades. 1980, 1990, 2000, 2010, and then 2020. Whoops. 2020. Okay, and I forgot to put brackets to make it into a list, so let me do that real quick. Alright, Alt-Enter, perfect. So now we'll use cut to design something that's called a category object. So Pandas has these category objects that's going to help us do this binning. So I'm going to make an object called decade underscore CAT for category, and then I'm going to call the cut method. So I'll say pd.cut. And for this method, I'm going to pass in an x and then my bins. So what that x is the object that I want to cut into a certain amount of bins. So I want to cut my years into different decade bins. Alright. So now let's go ahead and see what this decade category object looks like. So if you notice here, it counts off how many categories we have. So we have 6, 1960, 1970, then to 1970 to 1980, 1980 to 1990, 90 to 2000, etc., etc. And it's been able to cut my years into certain bins, depending on whether or not that year is in the decade. So I can check my categories using decade underscore cat, just the category's name, and I can call the method categories on it. And so that's going to tell me the index of the categories. So basically each decade, 60 to 70, that's a decade, 70 to 80, that's a decade, 80 to 90, etc., etc. Alright, so now the important part, I want to check the value counts in each category. So I can say pd.value underscore counts, which we've seen before, and I'm going to pass that category object into it. So this is going to count how many years I have in each category, or how many objects I have in each category in a general case. So in this case, I have 3 years between 2010 and 2020. I have 1 year between 1960 and 1970, and then there were 0 years between 1970 and 1980. We can also pass data values to the cut. So for instance, if I just wanted to make 2 bins evenly spaced based on the max and min year, I can do that. So to show you an example, I can say pd cut. I just want to say, go ahead and cut up that years list, and then just cut it up into 2 bins, and I'll state my precision to be within plus or minus 1 year. So let's go ahead and see what happens. So now my years, there's only 2 bins. They've been evenly cut. So now the bins are between 1969 and 1992, or between 1992 all the way to 2015. So all those years have been separated into 2 bins. So it's everything in the first bin, which is a time era of 69 to 92, and then it cut up the years into a second bin from 1992 to 2015. So that's about it for binning basics. Just a quick note, as far as the values of the bin itself, the notation of, for instance right here I'm highlighting a parentheses versus a bracket. So that notation is the exact same thing as in math notation. Parentheses means open, while using the square brackets means it's closed, so it includes that number. So for instance, this 2015 bracket, that means it's including 2015, and the parentheses means it's just open. So next up, we'll learn about outliers and describing data. Just an overview on binning, what we learned. You can use cut to bin an object either by declaring your bin list or by just saying how many bins you want to cut it into. And then that creates a category object, and you can call categories and take value counts on the category. And that's it for binning. It's just separating your data into different bins. That'll be useful for histograms in the future and that sort of thing. And I'll see you at the next lecture for outliers and describing data. Okay, I'll see you there. Hey guys, welcome to lecture 40. And in this lecture we'll be learning about outliers. Okay, so as always we'll import the usual. I'm just gonna start copying and pasting since we're doing this so often. Okay, so we got NumPy's NP, Pandas PD, series, and data frame. So we're gonna see how we can find outliers in a data set. So in order to do that, we're gonna use the NumPy generator. So let's just say np.random, and we'll use .seed. Let's just say 1, 2, 3, 4, 5. And so we've seeded our random generator, and now let's actually use random data frame random, and I'm just going to use randn, and we'll say 1004 as your inputs. So now we have our data frame. Let's go ahead and check a preview of it. So we'll just see the first few rows. Okay, and then let's go ahead and we can use tail to see the last few rows. Alright, so we got 1,000 rows and then 4 columns, index 0 through 3 and index 0 through 999 on the rows. Okay, so we got all our information. Let's go ahead and just describe the data. And if you remember from our describe summary statistics lecture, all you got to do is say .describe method. And so now we have the mean, the standard deviation, the min, the max values, and also the counts for each column. Let's just go ahead and select that first column. So I'm going to make an object called col, C-O-L, and then I'll say it's dframe 0. And then let's go ahead and look at col. Okay. So now I have the first 4 values in that column. 5 values, excuse me. So now we can check which values in the column are greater than 3. So for instance, I'll call column, and then as we've seen before, we can ask logic. So I'm going to say np.abs, so that's going to be the absolute value, col greater than 3. Okay, so what I'm asking here is show me column where the absolute value of the column is greater than 3. So let's go ahead and check that. Okay, so it looks like I got 2 of those. So I have row 523 and row 900. So those are both rows where the absolute value of the row in column 0 was greater than 3. So that makes sense. So we know now in column 0 the rows 5, 2, 3, and 900 have values with absolute greater than 3. What about all the columns? So how can I do that? So in a similar fashion, I'll now apply this to the whole data frame. Whoops. Should be square brackets there. And now I'm going to say np.abs of the D frame, the entire data frame, where it's greater than 3. And then I'll say any, and I'll pass the 1 as the argument. So I'm going to use the any method to do the same thing. So now you see here, it's returned every row in my data frame where any value that had a column that had an absolute value greater than 3 was returned. So I told my data frame, hey, look at the data frame, and where you see an absolute value that's greater than 3 in any column, return that row. And so these are the rows, and we can look at any one of them. So for instance, 3, 2, 4. That one, its value in column 2 was 3.26. So that's greater than 3. Okay. So we could possibly cap the data at 3. So how will we do that? We could say dframe np.abs dframe, so the absolute value of dframe again, greater than 3. So I'll set all those values, and I'm going to say np.sign of the dframe multiplied by 3. So what does that mean? What is this going to do? If we look at it again, let's see what we're actually asking the data frame to do. So we're saying anywhere in the data frame where the absolute value at that point is greater than 3, where the absolute value at that point is greater than 3, let's go ahead and set that equal to the sign of that value, which will either be -1 or 1, and then set it equal to that sign times 3. So that means values such as -3.18 here will turn into -3, and values such as 3.36 here will turn into +3. So we're going to go ahead and run that. Okay, and now let's go ahead and look at dframe and describe. Let's see what we get. So if we scroll down to the min and the max values, you'll notice now every min has been capped at -3, and every max has been capped at +3. Let's go scroll back up and see what we got before. So you see we had minimums below -3 and maximums above 3. So using this any method, we've been able to cap outliers. So you can use the logic and the .any in order to do that. Okay, so that's about it as far as outliers and capping them. Now, next we're going to learn about permutations. So I'll see you there. Hey guys, welcome to lecture 41. This lecture is about permutation. So let's go ahead and get started. We're going to learn how to randomly reorder either a series or the rows in a data frame. And that reordering is the same as a permutation. So we'll start off with the classic imports. NumPy is NP, Pandas is PD, and from Pandas import series and data frame. So let's go ahead and make a data frame. I'm going to say my D frame equals data frame. I'm going to use np.arrange. Let's just call 0 through 15 there, and reshape this as a 4x4 matrix. So that will be my data frame. And now I'm going to create an array with a random permutation of the numbers 0, 1, 2, 3. So I'll call this object blender, and then I'll say np.random, and I can pass this method called permutation, and I'll say 4. So what that's going to do is from 0, so if we count from 0 4 times, we'll get 0, 1, 2, and 3. And then that blender is going to create a random permutation of it. So if we see what blender actually looks like, Alt-Enter. So we got 1, 2, 0, and 3. That's the random permutation it came upon. So if we take a look at our data frame, right now all the rows are in order, 0, 1, 2, 3, and it's a 4x4 matrix from 0 to 15. What we can do to get a permutation of those rows is use the take method. So I can say dframe.take, and I can take blender from it. So what this is going to do is it's going to say, okay, from that data frame, take index 1, then index 2, then index 0, then index 3 rows, and put them in that order instead. So let's see what that happens. That results in, alright, so now I have 1, 2, 0, and 3 as the index rows, and it's grabbed all the values from that row and it's permutated the entire D frame based on the results of Blender. Cool. So what if I wanted to do permutation with replacement? So to show you what I mean, I'm going to make a little example. So I'm going to make an object called box. And let's imagine a box that has 3 marbles in it, labeled 1, 2, and 3. So I'm going to say box equals np.array. I'm going to say 1, 2, 3. So now I have my box with my 3 marbles labeled 1, 2, and 3. So just like Blender, let's create an object called shaker. And really similar to Blender, I'm going to say it's random, but in this case it's not a permutation since I'm going to do a permutation with replacement. So I'm going to say, in order to do that, I can use the method rand int. So this can be permutation with replacement. And so I have to do from low to high. So I'll say it goes from 0 to the length of the box, so the size of the box. And then I can say size, and what size will be is how many times I will pick from that box. So that will be 10. So what this is doing is it's basically just like if I scroll up here, made with Blender, it's going to do a permutation, but it's going to be able to do a permutation with replacement. So let's go ahead and see what this looks like. So I'll type in shaker. Okay, so shaker is now basically an array, and when we pass it through take, it's going to say grab the 0 index, then grab the 2 index, then 2 again, and 2 again, then 1, then 2, then 2, then 1, 0, 1. And let's go ahead and see what that looks like. So I'll make an object called hand_grabs, and I'm going to pass the take method on my box, and I'm going to pass the shaker on it, and then we'll see what that looks like. Cool. So now hand grabs is the simulation of taking a marble, seeing what number is on it from that box. So first I grab marble number 1, then I put it back in, I shake the box, grab another marble and see what number it has, etc., etc. And I can do that 10 times by taking that permutation of shaker. Okay, so that's it as far as permutation, and congrats, we're all done with this section. And up next, we'll start the next section, which is working with data part 3. Alright, I'll see you there.